A geosynchronous Earth satellite is one that has an orbital period of precisely 1 day. Such orbits are useful for communication and weather observation because the satellite remains above the same point on Earth, provided its orbit in the equatorial plane is the same direction as the Earth's rotation. Calculate the distance of such a satellite from the center of the Earth and the height above the Earth, assuming that the mean Earth radius is 6,371 kilometers. Mass of the Earth is 5.98 times 10 to the 24 kilograms. So what are we given? We are given time taken by the satellite to complete one revolution or one orbit. So time or period of a satellite is 1 day. We need this in seconds, therefore we have to get rid of the day. So we divide it by 1 day and multiply it by 1 day equivalent hours. That's 24 hours. We also want to get rid of the hour, so we divide this by the hour and multiply by 1 hour equivalent seconds, which is 3,600 seconds. Day cancels out with day, hour cancels out with hour, so we are left with 24 times 3,600 seconds, and that's equal to 86,400 seconds. So we are asked to find the distance from the center of the Earth to the satellite, as well as the distance from the surface of the Earth to the satellite. Let's just call it surface. Alright, now what relationship do we have? From Kepler's third law, we know that the period squared divided by its distance, to the power of 3, is equal to 4 pi squared divided by the gravitational constant G multiplied by the mass of the body. In this case, it is our Earth, so mass of the Earth. So what else do we know? We know that mass of the Earth is 5.98 times 10 to the 24 kilogram. And we know the mean radius of the Earth, 6,371 kilometers. Alright, coming back to the Kepler's third law, we can rearrange the equation such that R be on one side, everything else on the other side. So now this can be rewritten as R E sub S equals to the cubic root of multiplying both sides by GME and dividing by 4 pi squared. Therefore that will be TS squared G mass of the Earth and divided by 4 pi squared. Plug in the numbers. TS squared, we have converted the period to seconds, therefore we have 86,400 seconds squared. We know the universal gravitational constant, which is 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared. This is a table value. Times mass of the Earth, which is given to be 5.98 times 10 to the 24 kilogram. Divided by 4 pi squared. And that yields 4.23 times 10 to the 7 meters. This is equal to 4.23 times 10 to the power of 4 kilometers. That will be the distance of geosynchronous satellite from the center of the Earth. Now what about the distance from the surface of the Earth? Let's just call it RS. That must be equal to the distance from the center of the Earth to the satellite minus the radius of the Earth, which is given to be 6,371. So we have calculated the distance from the center of the Earth to the satellite, which is 4.23 times 10 to the 24 kilometer minus the mean radius of the Earth, which is 6,371. And that's equal to 35,929 kilometer, approximately equal to 36,000 kilometers. So the distance of geosynchronous Earth satellite is 36,000 kilometers above the surface of the Earth.